Okay, so good afternoon. My name is Paul. I'm going to present myself. I have noticed that most of you were my students in some time in the past. That fills me with joy, I must confess. That's very nice indeed. When Pedro reached out to ask me for subjects to speak in this event, I thought I don't feel I have anything important to say. I've been studying for a while, and some things seem obvious, and I thought, well, I don't have anything really important to say, and so I started to exchange some topics, and I threw this one to the air. Immutability, is that interesting? And so he said, well, it is, because I am not yet convinced of its merits. And so I took the challenge, and I will try to change your state by defending that state should not be changed. Okay? So let's start. A bit about me. What is my intent here? My intent is simply to state that I am fundamentally a programmer. That's what I do, okay? I love to code. That's my main interest. I know that software development involves many things. All those roles are very important. I've been in several, but the one that I love the most involves coding almost every day, okay? This is important to state because I know what it means to code on the wild. Okay, I've been there, I've lived it, I know how it is. But for the last 4 years, I've been fortunate enough to spend most of my time teaching. This means that I have time to think. Okay, I don't have to deliver and deliver and deliver. Okay, when we are working on the job, we must deliver. It's not about anything else, it's about delivery. And ideally, do perfect deliveries, okay? Ideally, I said. So when I say I am a programmer, what kind of programmer I am? I am an imperative programmer. So I am used to say to the computer what I expect him to do. It or him, that's the discussion of these days, right? But I expect it to do as I say, okay? And this is not necessarily good. So we'll get on that later on. I have used professionally those languages. I started with assembly and C, afterward, and C++, of course, also. Afterwards, Java for many years. Java and C#, I used it for almost until Kotlin. So it was almost 20 years, yes. Also JavaScript or ECMAScript, if you prefer. And finally, since 2017, Kotlin. I've fooled around with others, but that doesn't count, okay? I'm speaking of code that I have written for someone who have paid me for it, okay? Not for fun. That doesn't count here, okay? But I have used Scala, Clojure, and whatnot just for fun, but that doesn't count. Regardless, I am not a language expert. If you expect me to know every corners of Kotlin, I don't know. And I'll say why. Because I like to speak. For example, I'm not speaking in my native language, but for example, in Portuguese I speak, but I do not use all the words there are in the dictionary. And I believe that in programming languages, that should be the same rule. I don't have to use all the constructs, okay? They're there, but I don't have to use them all, okay? So this is how I think about writing programs. But enough about me. This is provocative. It's not my intent that you actually respond, but my questions are out there, right? For any of you, are you full-time programmers? For how long? How many years of experience do you have coding almost every day? If not, why not? And if you are still doing it, how long do you intend to continue doing it, and why? You don't need to answer. I've been there. A great friend of mine said to me once, coding is a dirty job. okay? So I know what it means to deliver. Sometimes we ask forgiveness before the commit. Right? We are, oh, forgive me, God, for my sins, and there you go, commit. Okay, so it happens, okay? But that pains us. It breaks our hearts. And eventually, it may lead to disappointment on coding. I've also seen that. I remember, I use this just to state that this is Frederick Brooks. If you don't know him, you should read this book. I've talked to you about this one already. You should read this one. It's a book comprised of a set of articles, essays, where he discourses about in the industry, software industry, 1975, okay? And I think this phrase captures the general idea of what I feel about coding. And there's some of you are nodding because it's something difficult to explain to other people. When we see it moving because we did it, it's something, well. I will show you some code later on, and simply because I made it work, it fills me with joy. They already seen it 4 years ago. It's adapted for some of my classes, but it's just the sheer joy of making things, okay? I'm aware that for building software there are many contributions, important, all of them. It's not about comparing. It's about highlighting what I love most, and this is coding. But that is not everything. It's not everything roses, okay? It has problems because we must perform, as again Frederick Brooks says, we must perform perfectly, okay? And there aren't many human activities that demand that, to perform perfectly. If we don't perform perfectly, the code doesn't work, okay? Either the compiler says no, or the automated tests say no, or worst still, someone down the delivery pipeline says no. We hope it's never the client, right? The end user, we hope. So, oops, sorry. So, remember, I am an imperative programmer. I've been coding for almost 30 years now. I started coding around, professionally, I mean, around 1996, maybe. Yeah, maybe around that. Professionally, I mean. And this is the gist of it, of my talk. Mutability, most of us do it out of habit and not out of necessity. That is my argument, okay? Too long, didn't read. It's mostly an habit of us, imperative programmers. We should use another approach for the sake of simplicity and sanity. That's it. If you ask software architects in the large scale of things, most solutions do not involve the deletion or mutation of data at the large scale, okay? Nobody goes and deletes an entry in the database. That doesn't happen unless it is necessary because of RGPD issue or RGPD, okay? Otherwise, data is not deleted because we need to do profiling, or we have to be liable for what happened, and we must keep everything. So, but I'm not here to talk about software architecture, because if you look at software architecture, is about mostly about identifying the parts, the anatomy of the solution, the body parts, if you wish, okay? And the relation between them, what is the function of each of them and their relationship. Here I will talk to you about, at the cellular level, the fabric, okay? We like to think that, I was also software architect, we like to think that software architecture has a huge impact on the solution, and it has, but for instance, when you look at the solution around 2-3 million lines of code or more, comprised of a set of components that each other has about 50 60, 100,000 lines of code easily. The boundaries imposed by architecture are not enough to ensure the robustness of the solution, okay? And this is a problem in some, I would say most organizations. So we should handle it at the cellular level. So look, anytime, if you wish to ask something, please do. My English is not that good, so feel free to interrupt anytime, okay? So I think this is mostly common knowledge, okay? Back in the day, I started coding as a kid. I used the Spectrum 48K of memory. This was at, well, back in the day. But let me, I had a nice conversation with GPTO. Let me show it. And it's here, I think, yeah. It's a great tool. I use AI every day because I can. I know that there are restrictions imposed in some organizations to use it, but, well, at some point I got fed up with simple mistakes. If you look at the graphic, you will see that something is wrong. Yes, of course it is. I tried to convince him that something was wrong, but it's not awful. We can understand it. This says that it's memory in gigabytes. My intent, of course, it's not in gigabytes. I told him 3 or 4 times to correct it. It couldn't handle it. It couldn't. I have the conversation linked. Okay, the link is on the slides. You can see it. Otherwise, it just gave me the information I required. And it's mostly about looking at this graph and see, okay, it seems right. The numbers are here on the right, okay? And this is the evolution of memory size along the years, okay? Remember, I started coding, and maybe most of you learned to start coding with people who started coding at this time, around 1993, 97, 99, around here. Our computers had 32 megabytes of memory, okay? Most computers had that memory, right? So this means that space was heavily constrained, okay? Heavily constrained. It was expensive. Look at what just happened since then, 1997 until now. It's not 30,000 gigabytes, okay? It's 30 gigabytes. An average computer has 16 giga easily, most of them 32 nowadays. We go and buy one off the shelf, 32 gigas is the bare minimum for a machine to last at least 4 more, 5 more years, okay? So this means what? The target has changed fundamentally, okay? There are many diverse computers. They are distinct. I have one in my wrist, so do you, in your pockets. And most importantly, the constraints that originated some of the languages that you can see here. So look, for example, C and C++. There's C 1971, C++ 1983. It was one of my first languages. And Java 1994 or 5, something around that. I'm not sure, but here it is. So those languages were created when computers had restricted memory sizes. Of course, there was Lisp, ML, Scheme, but those were the funny languages, okay? Nobody used them to do real work, okay? I'm not advocating to change languages, okay? So the point here is something has changed, mostly the target. If the target has changed, should we keep the old habits? Should we need to hold to those old habits? I advocate that using immutable data simplifies things, okay? So I usually don't do slides. I couldn't, Opa, a malta está aqui. Wait. PowerPoint. Let me just fix this. Something on the, okay, wait. Thank you guys for telling me. The stream, yes, it's something on the stream. And properties. And this is okay. Link. It's the link who's misbehaving. I don't understand why. It's not me. It's just Murphy, yeah. I don't know what I can do. Let's just let me, but the stream is not behaving well because, yeah. Projector, properties, display capture. Let me change again. RZOPA, and now again. Okay. Oh, terrible. Sorry, guys. Okay. Think it's good. No, it's not good. Damn. Let me just like this. Let me just, okay. Okay. We can handle this. I don't need to do this. Ah, come on, really? I don't know what's happening, guys.
Press Ctrl up to
Control.
get all the windows.
Oh, damn. Wait, no. Let me just quit this. Okay. It always works. No, right? Let's start this again. Okay. Not this. Desktop. Talk. Open. Okay. No. I don't understand what's happening. I can't fix it. Okay, guys, let me just try this and this, and finally, I must proceed. Wait. Damn. There's something wrong with this. I'm unable to fix it. So I think the best thing to do is to end it. See? Yeah. We continue live and lose this. So I can't fix it in a timely manner because yeah. Mm-hmm. Yeah. But the point is, the question is that because I'm streaming live and I need my computer to stream live and something is interfering with the resolution of my stream and I'm not sure what, and I don't know how long I take to fix it. And so in that case, the best thing to do, I reckon, link. This is, let me just add another one. I will hide this one. Let me add another capture. Maybe I can. Let me just try this screen capture. Okay. 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 Yay! I guess I fixed it. Okay. 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 Sorry about that. It's good, right? If anyone is seeing it, yeah, it's good. Yeah, it's good. Okay, great. Don't touch. It's good. Let's go. So I was saying, whew, that made me sweat. Murphy's. Okay. So I was advocating for simplicity. I was stating earlier, I love to code, but I don't. When I'm coding, my intent is not to build puzzles. For puzzles, I use puzzles. I like code to be simple enough for me to understand it at first glance, okay? I usually say to my students, look, I've been looking at code for 30 years almost. If I look at your code and I don't understand it, it's not good. I know it's a bit harsh, but really, if we write code, it's for others to understand. The computer just knows about bits, right? So we should write code easy to understand. So this is simple enough, right? Is it? Just imagine I couldn't help myself, so I made a small animation. Just imagine that variable moving around the great vastness of space code, okay? It's there, moving around. And the question pops in your mind. What's the value of count? And the answer is, I don't know. So this is not simple, right? And you say, no problem. I'm black belt in object-oriented, right? I know. But before that, this is simple, right? It's also in the emptiness, in the empty vastness of space code. What's the value of count? It's 5. Now, there's nothing wrong with it because it's global knowledge. In global knowledge, it's fine, right? But I'm a master in object-oriented. I have a black belt. I know all the design patterns. I've read countless times the book of the Gang of Four, countless times the books from Enterprise Design Patterns from Martin Fowler. I know them all. So I can handle this, right? No problem. Let's encapsulate. Encapsulation is the tool, isn't it? Is it? So, like this. Is this better? So I've coded a little counter Java style, okay? Java style. Here's the counter. I used very simple examples because if we can mess up simple examples, oh, surely we will mess up harder solutions, right? So here it is, a simple counter. Do you see any problem with this? See this counter? Is it okay? Is it good? What I do, I encapsulated behavior and state. State is mutable here. But I hide the operations for changing that state, regulate the access. I ensure that the counter never exceeds a given maximum capacity, right? This is all fine and dandy. This is good, isn't it? Can anyone see a problem here? Not thread safe, precisely. If we cannot say without a doubt that this is correct, it depends. And we don't like software that depends, okay? This is not correct. And mostly it's not a good idea, okay? So why not? It's not a good idea. I instantiate that counter, and that was the definition. Is this better now? Did actually encapsulation solve the issue? No, not really, because the state changes. If I pass around my counter to here be dragons functions, you all know that there are functions like this in real code, here be dragons. We cannot pass our counter like that, can we? What do we do usually? When we pass our instances with mutable state for a function that here be dragons, we do a defensive copy. We copy them and we pass them around. Okay? So it's not only about the argument about thread safety, it's also about the argument that encapsulation by itself solves nothing. It's about scope. It's about scope of the mutation. And this didn't reduce the scope of the mutation. The object is still perceived as a mutable state, okay? Regardless of having a couple of operations that regulate the access to that state, okay? So regarding this, we cannot say prior to the call what was the value of counter, and after the call, we cannot say what was the value of counter. We were talking about thread safety on the previous example. And no problem. I'm also a black belt in concurrent programming. Okay? No problem. Everyone knows that this is very easy to make thread safe, is it? Well, I will not enter in many details, but you guys know all the problems. I know for sure because you were there. But for example, it's not only about atomicity, it's also about publishing the value. So I cannot ensure thread safety only in the type definition using synchronization. It's not possible. I have to make sure afterwards that this is correctly published because it's mutable state. Okay. But because I am black belt in concurrent programming, I could put some synchronized here, which there's no synchronized in Kotlin, and there's a reason for that, but that's not my point now, so I'll move on. I was saying, let me just check that everything is still going on. Okay, Gango 4, yeah. So I was saying, this isn't appropriate. It's not good design, okay? It's not because I've placed the mutable state protected by a couple of operations that this became good now. Okay, but how should we go about it? There's a simple example. If I create this counter, and this counter definition is right here, now I can state it's correct, and I can state that I'll share the code. It's not rocket science. It's simply val and val, okay? Val all over. I simply know that counter is a value. And that value is always the same, in this case, 0. If I intend to produce a new value, I call an operation on this counter, which produces a new counter, and I hold on to the new value. Okay? So it's not about objects, it's about values. Okay? So what would happen if we reduce the mutations to a bare minimum? Look, I'm not, again, I'm an imperative programmer, and I'm not advocating let's change all our ways. I'm just saying mutable state is dangerous. It's difficult to deal with. It's necessary, of course it is, but it's dangerous because it's complicated, okay? So what if we reduced our mutations to a bare minimum, to what is essential, by creating models that are comprised of immutable data and making data flows explicit, okay, in our use cases? What would happen, okay? What would our code look like? I've built a small example inspired in something we did long ago. This mindset has been introduced to most of Lake students on the past 4 years, right? You started 4 years ago. We started by doing this. I will show you the code just in a minute. We started by doing this. We will, in our design, we'll favor values. That is, value-oriented programming style, if you wish. Okay? Immutable data. There is a single point of mutation that we were allowed, okay, to the students. Students could use only a single point of mutation. I will show you where in a minute. The computation is done in two phases. The first phase, I compute the new value of the application state. In the second phase, I commit it. Okay? If you already use, for example, Android development and you are using Jetpack Compose, you know this is the way, right? If you try to do something different, you will suffer. Because it is thought of to be this way. First phase, you compute the new state. Second phase, you commit it to a mutable state holder, okay? So that the infrastructure by itself determines, oh, there was a change here. Let me recompose and produce a new user interface. How does this look? I understand that there are eventually some concerns. Let me show you. This is a code base that was mostly built 4 years ago for students that are starting to learn how to code. Okay? So this uses the most simple of techniques. It's an unfortunate time. We are at war, but Europe is at war. But, well, it is inspired on missile command. So I just did something that allows us, remember, this is for first-year students, okay? It's for them to have fun. I think this is fun. Well, it is for me. I like to game. So, okay? What's nice about this is that I can fix, I do this, and then I can do this. Right? And then, wait. I can stop, do forward. Well, not. There's a bug there. No unit test, right? Right? The state machine for you what? Yeah, thank you, yes, please. I'm dying here. No, it's good. Okay, it's fun. What you just saw, thank you. What you just saw is that it's something that is not possible if we model using mostly mutable state, right? I'm taking a snapshot of each application state. I'm recording them all, and afterward, I'm replaying them. And I can do this for a long time, but I have capped it to 10,000 snapshots, okay? Whoa, that's a lot. No, that's not a lot, okay? And 10,000 snapshots, it's around, well, I'm snapshotting at around, I intend to do at 40 FPS. I'm only accomplishing around 33, so it's some FPS per second, some frames per second. It goes for a long time. It's not that much. But regardless, we can say, well, that's fine, but that will take too much space or too much time. Let me show you the techniques, how simple they are. First of all, I thought of the application state mostly of immutable data. And there is a single point of mutation right here. You can see here, just right here. There's a game. Game is a data class which holds all the state information, including the history of snapshots. And every time a new frame needs to be constructed, what I do is I build the new state, and then I store it, and then I draw it, okay? Every time I do next, what happens is this. If I'm playing, I compute the next state, and I store it. And I store it in a snapshot, okay? Again, copy all around, okay? I never use previous instances. I always create a new one, okay? So this must be quite expensive. Compute, replace, snapshot. Compute, replace, snapshot is, look at how simple the techniques are. I have many copies here, and game is this, okay? Game, it's this. It's too large. a world in a mode and replay info. Replay is a history with a current index and a mode, all vals, no vars allowed. Okay? Let's see how this behaves. Okay? I will pump it up a bit by doing this. Instead of throwing a new missile every second and a half, let's do that every 100 milliseconds. Okay? A shower of missiles. I don't intend to play, okay? It's not about trying to deflect all those missiles. But let them rain, okay? There are a lot. You have a super machine. Not real. It's staggered but there a while, but let me show you. I have a better idea. How about JVM, Visual VM? I made some measurements earlier, but I will not go into that. I'm talking for how long now? 30 minutes? Okay, thank you. So let me just run this. Oh, by the way, regarding thread safety, you know there are 3 ways to deal with thread safety. The problem is shared mutable state. So the first, the ideal approach is mutable state. Okay, don't mutate. Let's have immutable data. This is the solution. It's thread safe by definition. I think it's this one, right? Yeah. Have to. Okay. The other solution is, okay, shared mutable state. Let's not share it. It's called confinement. It's used, for instance, in Spring. Each request is handling is confined to its own Spring MVC, of course. Each request is confined to its own thread of execution. Or, for example, in UI English, there is a single thread allowed to execute event handlers. What you see, it's not that much, right? Well, actually, I'm using persistent data structures. I'm not using regular immutable data structures. Okay, I'm using persistent data structures, which are constructed explicitly to simplify or to optimize this approach. Where I want to have a new version of the data, I build a new list, okay? Or I build a new graph that represents the application state. But while doing it, I use what is called structural sharing. Not everything is new, okay? Many of the data that is already there, it's still used on the next snapshot, okay? Because it hasn't changed. It goes, it rises, and it descends. What you will see, if I would let this execute for a while, we'd have, I think it's here. Okay. You see there? This is the result of executing during 15 minutes, like this. What you see is the famous sawtooth garbage collector is doing its job. And here, the point of stability is the size of the history I preserve. Remember, I keep the snapshots, okay? So I don't throw away the old data. I just kept it at the level that it's tractable here, okay? So this is the end result. And this will slow down the execution, a big reduction, but let me profile this. Let it rest for a while. Okay. Look, what just happened. It's the profiling, okay? I'm doing this Why? So we can look at the hotspots and how many, what is the percentage of time that the only thread of execution, okay, where it spends its time, okay? If we let it do its job, we will realize that most of the time this thread isn't doing anything, okay? So it's, I should end, right? Okay, okay. So my main point is this. I'm not advocating let's not ever use mutations. Of course not. I'm an imperative programmer, remember? Let's just use them where they're needed. In this case, for our first-year students, we allowed one mutation. Our experience with this is that they are here. They could say if this is not true, but our experience was that generally the students could handle more code than usual, solutions with more code. For example, prior to this restriction, some students or many students lost, couldn't handle their code anymore. They couldn't make any changes because any change will result in a bug which they could not fix, okay? In this approach, we experienced that this didn't happen so frequently. Why? Because the data flow is explicit. We can understand clearly where the data ends, how it is transformed, and where it exits the pipeline of transformations, okay? So this makes the data flow explicit. And explicit makes it easier to understand rather than something magical happens somewhere, okay, inside something, okay? This is not ideal, and remember, this is based on a little library that a colleague of mine built for educational purposes, so this is not optimal. And I must say that I haven't done extensive testing on this. It's not, I think it's not difficult to understand that this can fail in some cases. For instance, game development. Is really this approach appropriate in game development? I think it is, but I'm starting a PhD to get to the bottom of that, if actually that's true. But I think it's possible to use even in game engines, okay? But someday I will talk about that. For now, I admit, okay, maybe not. But in all other scenarios, at the application level, this approach is not only feasible, but it's desirable, in my opinion, okay? Notice that here, this does not reflect an actual programming model of a game engine, okay? Here I have several points where I write the new state because I do it separately. When on mouse down, I fire a missile. On time progress, I fire an attacker missile. On time progress again, I compute the next frame. Okay, this could be done in only one place, and that's how it's made on game development. And that place is the loop where I observe the inputs and react accordingly. Here, this is event-driven. Okay, in the game engine, that's not event-driven. Finally, and the games. Finally, let me just. Okay, I think it's enough. Okay, stop this. Okay. And let's just see what the Visual VM has to show us. Here it is. Yeah. Just look at this, and we will see that. You see how long we executed? 151 milliseconds. That's not a lot. 1.5 seconds actual execution of the thread. Okay? Hotspots. Let us see where they are. The draws are expensive. Okay, compute next, compute and the next. Oh, next is expensive. Okay, cool. Expensive, that is. Oh, 50% of the time. And where? Oh, remove exploded missiles. Oh, detect collisions. Oh, okay. We drill down and we see, okay, this is mostly about computing whether a given missile is to explode or not. It's not about add to lists or plus on lists or what we would, or copies. There are no copies here, okay? Well, they are happening, but they are not highlighted as hotspots. Finally, if you like, this code is available. You can look at it and eventually look at the drill down of this and make up your own minds. Finally, my argument is this. At the application level, there's no need to use mutation most of the times. We should restrict the usage of mutations to specific places, okay? Most of the times we don't need it. This produces a coding style that makes data flow explicit and easier to understand, and therefore, and also easier to test, because I throw something into a function and something comes out, and I observe the result of what comes out, and if it's okay, the test passes. If, on the other end, there's some mutable state inside something weird down the line, I need to test that. Either I have to add new operations on the public contract so that I can observe the internal state, or, well, I have to be creative, okay? So I think it's a nasty habit, and for the most part, it should be avoided. There are, I use this, by the way, in Android also, okay? Where I also restrict the mutation to a single point in each screen, but I will not, don't have time to talk about that. So this is the main point. Don't take my word for it. If you, I have some references here. Some of them are priceless by very intelligent people. The first one, values and objects. People tend to confuse them both. One thing is a value, other thing is an object. An object has another identity, a value doesn't. This is why an object is more complicated than a value. This article by McLennan is very good, very good. The Value of Values by Rich Hickey, the Closure guy. If you don't know him, that's the Closure guy. It's a video, brilliant video. He's a brilliant man. The function, this one you all know. If you are like me, object-oriented programmers, you know Uncle Bob, of course, right? Just watch this video. And watch the father of solid principles. Is not the father of them all. He's just coined the word solid. Okay, the SRP, the SRP, the O, and the other principles were coined by were invented by different persons. Most of them, I think, by Barbara Liskov, but I'm not sure of that. You can watch this video; it's great. Regardless of Uncle Bob's views of the world, he's a great speaker and a very intelligent man. This one you also know, of course, Roman Elizarov. You all know them, right? If you use Kotlin, you know who this guy is. It's an article, Immutability We Can Afford, and Pat Elland, Immutability Changed Everything. Well, just so you don't think this is, and I told you of Value of Values by Rich Hickey, which is a functional guy from Closure, just so you don't think this is a thing we are importing from functional language. That's not true. These are some books I've read in the last 4 years. Code That Fits in Your Head by Mark Seaman. He also advocates the same. Data-oriented programming, it's a different approach to design, software design. It also advocates for immutability. Domain-driven design by Eric Evans, everyone knows this one, of course, but he also advocates for immutability, okay? He speaks of how to do object-oriented properly. This one, a great book, Domain Modeling Made Functional by Scott Vlashin. And finally this one, okay? So all of them are great. I've read many others, but I think those are the best ones. I know I have the time to read them, okay? I'm not judging, but if you have the time, okay, at least look at this. And if you're already using these ways, you're good to go. If you're not, maybe you should give this a thought and think it through. Should we use this? Should we change our habits or not? A student of mine in the last week said to me, I was trying to convince him of build user interfaces by designing state machines, okay? This is nice to do, for example, in frameworks like Jetpack Compose, or, for example, React. We think of a screen is a state machine has transitions between states. And for a given state, I produce a given UI. I was trying to convince the student about the value of immutability. And at some point he told me, can't we do like I am used to do? And I looked at him and I thought, really? You are doing this for what? 2, 3 years, and you want to keep on doing like you are used to? I'm doing this for 25 plus years, and I'm changing the way I do it. So why would you not try to do better, okay? So I'm really convinced that the end result is clearer code, okay? And if you are using TDD, this will come perfectly in your context. It will, look, if you are mocking a lot, you're doing it wrong, okay? It's not the way, it's not about mocking everything, but that's another topic. So thank you very much for your attention. I hope it helps to broaden, or better yet, I hope it's boring and you already know this and your code is pristine, lovely, and uses immutable data everywhere, okay? Thank you very much. Pronto. We're live, wait.
Só preciso do microfone.
Ok, toma. Demorei muito, desculpa, pá. Graças.
Faz mal.
Epá, já tudo assim. Podes fechar isto. Consegues orientar, não é?
E não sei, ele não está a responder.
Tá.
Está aqui um bocado levantado.
Podes fechar o gajo, podes fechar. Ah, sim, certo.
Ok. Konsist era para o Tiago.
Ok.
Não é este.
Lá no desktop. Podes fechar tudo que era meu podes fechar, né? Tranquilo.
Não, estava só a deixar o Konsist para o Tiago.
Consiste nisso. Pode ser, isto eu fecho, que é para tu pôres. Ok, isto também fecho.
Isto não agarrou, porquê?
Isto também fecho. Está feito, pronto. Já te li tudo, não é?
Tem que deixar assim ou posso pôr em...
Não, podes, como tu quiseres. Estás à vontade. Acho que aquilo está tudo ali. Tá, vamos.
Está ok? Ok. So, hello everyone. Good afternoon. Before we start, I want to thank Kotlin Lisbon Meetup group for allowing me to present to you here today, and also to see so much of a big attendance here, and also first time for me to be part of a live stream. I must confess, I have done some presentations in the past, but never in a meetup level and never in a live stream, so I'm a little bit nervous, and then coming afterwards after a presenter like Professor Paul that had already a lot of students here, I'm feeling a bit of the pressure creeping in, but let's see. I hope you still enjoy the presentation. I'm gonna be brief. The agenda is quite small. It's gonna be just a small introduction about myself and also about our backend community. We're gonna talk a little bit about also our journey, Kotlin's momentum, and then I would say lessons for the road, but with a grain of salt, because I'm no expert, but I think, I hope at least that this motivates you also in your own journeys of transitions. So, who am I? I'm Gonçalo Montalvo Marques. I'm a software engineer with a focus on backend. I'm here at Mercedes-Benz IO since 2018. I'm also, since 2021, here in a company, backend community of practice lead. My interests are varied, but I'm really interested in learning more about open source and DevOps. And yeah, I'm based here in Lisbon. Having said this, let's go directly to to the main part. And maybe you noticed something that was like community of practice lead, right? What the hell is that? Actually, in my day-to-day, my primary role is of a backend engineer. I'm a part of a Scrum team, developing and so are all of our backend engineers doing that, and they're inserted in their product teams. But I also have a secondary role of a community of practice lead. And what is this of a community of practice? Basically, this was a concept that was introduced in the 90s. That was introduced in the 90s by Jean Lavre and Etienne Wenger, that they basically discovered or realized that people learn better in groups when they have a shared interest, right? And so in a company, we have that to share that and grow with learning together. Maybe if I mention the Spotify organization model, does anyone know? Okay, right, they have these squads, those are product teams. They have tribes, which are like programs that aggregate those product teams. Then they have guilds and also chapters. Chapters is kind of the communities of practice, and then they have the guilds that's kind of communities of interest. It's kind of the same, while communities of practice is more like roles that you have that are together and have some interest. Community of interest is like a specific topic that you have. And so in Mercedes-Benz IO, we have that. And we develop microservices and also maintaining the backend infrastructure and all of that. But our core values or tenets in the community are the ones that I have here. And I think this also motivated the culture that we have and led to this adoption of Kotlin. The first one is the broken window theory. I don't know if anyone has heard of it. It comes from policing and crime. It basically states that if there's in a community in a community there are signs or visible signs of civil unrest, criminalization, and that can foster continuous more criminalization occurring, and then it can go from there. In software development, it's basically for us to adhere to this broken window theory in the sense of let's not leave broken windows in our code. If we have bad designs, poor decision making that we're doing, let's fix that, because we can really cascade this down and have a snowball effect that we leave this one bad habit here, then another bad habit there. There's a code base that is now completely bad. Then it starts with a team, maybe a whole culture that now we just like keep on going, and we leave a lot of issues in our code. Second one, done is better than perfect. In my view, perfection is impossible, but that does not mean we should not strive for it. And I think this value, the way I interpret it, is that there comes a stage that we cannot be always planning and just considering all of the use cases, all of the scenarios, and you just need to really go for it and put it in production, right? If you know Josh Long, he says that his favorite place on the world is production. So I mean, done is better than perfect. Let's just go for it and then do something and iterate from that. Which connects to the other value of experimentation. I think that's self-explanatory, but it's quite, I think, lived in the sense that we are encouraged to try out new technologies, new approaches, talk about it, iterate on them, and this brings us forward in trying out new things. Which connects to the final one, that is, if it doesn't hurt anybody, let's try it. I don't really like this because it's a bit abstract, but the way I also interpret it is, I mean, you experimented with it, okay, that's fine, but now let's actually use it somewhere. And unless you can consider some sort of, you think about it and you see, okay, there's a blocker here and there, yeah, sure, that's hurting somewhere in the code or what you're doing in your product, fine. But otherwise, if there's no real objections, let's say, let's go for that. So having said this, I think, yeah, this is something that is kind of interesting in our own setup because we have this community that moves us forward. So let's go to our journey. But before we start, we did this poll in the beginning, but I would still like to understand, again, who is using Kotlin in their day-to-day at work. Okay. Yeah, a lot of expected in a Kotlin meetup. That's nice to see. And in particular, does any one of you that is actually using it in your work, was there like a transition from Java to Kotlin? Okay, I see some hands. And does any one of you want to share? Was it easy to migrate, to transition in terms of knowledge? Yeah? Yeah, that's the view that I also have. So it's nice to see that some people also felt the same. So going to our journey. So the company started in 2017, and you see there two backend engineers. As I said, I joined in 2018, so I was not part of it. So also some parts here are recollections and interpretations from my side. Don't quote me on all of that. There are other people here that you can network later that were already here in those times. And I think it really started with one thing that was this Kotlin experiment by one team. And I think this really was the engine for our change, that one team decided to go for it. So let's just go do our first pit stop here and do a deep dive on that. Before we go there, I think we should set a bit the context of 2017, 2018, right? So long ago, before COVID and all that. Everyone was mostly using Java and Spring, as we were also at the company to develop microservices. But in September 2017, Spring Framework announced their support for Kotlin. That was really big. And also Webflux, which is a reactive framework that they introduced. And also in September 2017, Java, Oracle announced that they were going to change their schedule, their release planning schedule that they had for Java, because at the time it was very slow. But this was going to also take some time to take effect. But it was interesting to also have that in mind. But later on in 2018, in April, they announced that they were going to do some changes on their licensing model. And starting in 2019, 1 year after that, more or less, in Java 8, new updates of Java Standard Edition 8, they would not be available to anyone without commercial license. So this kind of also started maybe like when you're going to go to, at this time, in this time frame, Java 11 was coming out in the end of 2018. And maybe you go to Java 11 or not, maybe you start to consider options, because if you're going to go with Java, you can consider it, but maybe you need to use another licensing, another distribution for Java. And then Kotlin is coming around, and in October of 2018, Kotlin 1.3 announces that they also have coroutines in their release. I'm no expert in coroutines, but basically what I can try to say to you is that this allowed for to support a reactive paradigm in your code, because you could write asynchronous code there. And it was something also that we were like, okay, this is kind of interesting. And so continuing on after having the context, what was happening here? We had one specific team that was already really established and had some really strong technical and experienced people. And they had this new challenge that they had a new requirement for their product. They needed to fetch a lot of data. They needed to be, the way they analyzed it felt like an event-driven architecture made sense. So already some views on, okay, reactive programming could be something interesting to consider. They also were seeing Java development was slow. We were at that time that Java 8 had optionals, had streams and all of that, but the jump from Java 8 to Java 11, in my opinion, was not that big, and Kotlin was showing up with things that were like amazing, right? Not having to have Lombok or a map struct for your Java classes in Kotlin was like, oh wow, maybe we should consider this, right? And then Kotlin, since it was a JVM-based language, it fits in our ecosystem, in our infrastructure, and it's really interoperable. You could call it from Kotlin to Java, Java to Kotlin, start with one library, start with some unit tests, and yeah, and then they also had, of course, to consider what the professor was also saying about delivering something, right? But they were really confident in that sense, and that this was a really big boost to see like a really experienced team going for it and trying this out. So going on in our journey, you also see that there in 2018, we had some colleagues attending Kotlin Conf. I think that was also really interesting, because more people were getting context what was happening in the Kotlin ecosystem, bringing it into the company, evangelizing of sorts when you went to the conference. What were the main topics? What did you see? What was relevant for us to consider? We moved in 2019. You can see here also a jump in our number of backend engineers, right? Not that big, we're not that many, but you can already start to see that the communication flows will also be a bit different. You'll not be aware of every product team or everyone maybe. So it was important that in 2019 we had a knowledge exchange session with this team. And basically they came to our community, they did a presentation explaining, okay, we are using Kotlin, we are using Webflux. At the time they went for Webflux before switching to coroutines. They were considering that, but at the time it was not that as mature. They shared it with the company, what was happening in Kotlin, in Webflux, what was working well, what was working not so well. Maybe you should consider, oh, if you're going full reactive, no blocking operations, no blocking drivers in your code. You should know that there's some not so useful stack traces. You need to consider it's going to be a pain in changing to reactive. But also this slowly introduced people to also seeing Kotlin code and seeing what was happening. And then people were also asking, oh, you also showed Webflux, but Kotlin has coroutines. Are you considering this? And also that, okay, another reason to consider, because that was also in the back of the mind of everyone. So if we continue here on our journey, we reached 2020. There was also here the Maven archetype. That was an interesting thing that I will also focus next. And also an ADR for our backend tech stack. So we do here our second pit stop, let's say like that, and expand a little bit. So, I mean, most of you are probably familiar with Maven, right? Okay. So Maven is a build automation tool. And the Maven archetype is basically a templating toolkit in Maven. What this means is that you can configure some class files in template mode. You can already put a POM with some dependencies, and someone can run that and then already have a blueprint of a new project that they want to create. And since 2018, we already had that for Java, but not for Kotlin. So we decided as a community, this was not something that the product team was doing, just like some members of our community decided like, oh, let's be good to have this, because 2018, the Kotlin bug was spreading, more people were talking about it, some people were starting to use it, but not such a Kotlin first approach or mindset. And this basically allowed an enhanced developer experience, because it made it quite easy for anyone that was coming from Java and already had some, okay, what are the libraries that maybe the other teams are using for testing in Kotlin? What are the dependencies that I need to know? Or how the code looks like. Oh, I don't need lone block and abstract now. Yay, nice. And so, yeah, this was really something that also helped increase the adoption. And then architectural decision record, I think maybe a lot of you know that what that is, but if you don't know, really, in short, is basically a document that records some sort of architectural decision that was made, and also the context and the impacts of that decision. And what happened is that we had some architects in our company that were doing ADRs for different sort of things, and one of them was on the backend tech stack. And they codified there that Java and Kotlin were our main languages. I do here a small heads up. That does not mean that, no. One of the things that they codified was that Kotlin was the preferred approach for every new microservice that you were developing. And here is where I do my heads up, sorry. That this does not mean that everyone is now already in Java, in Kotlin in our company, or that at the time everyone was already, oh, I'm going to develop something new and it's going to be in Kotlin. Because again, there's also a small, I think, a small learning curve in doing it, and also product has and business has its needs, and of course there's going to be impacts on your delivery if you're not confident on what you're delivering. So not everyone immediately switched, but a lot of teams that had the time and space to experiment, fill those core values that we were saying, actually started to implement and to transition to Kotlin. So I think those two together were also a big point. And then if we go to our journey, 2021, I don't know, maybe COVID happened and I didn't put anything here. Maybe my mind is drawing blank. Maybe something else happened, but yeah, then in 2021, really in the far end of it, I feel like our community was more or less in that vibe that, yes, we are Kotlin. Anyone that was in Java felt a little bit bad that they were not in Kotlin. They were like, I'm still not in Kotlin, guys. But we felt also that outside of our community, maybe our product owners, maybe our Scrum Masters, maybe, I don't know, they were not aware of what was Kotlin, and every time that you were like in a product meeting saying, maybe we should try Kotlin, they're like, what is that? I don't know. And then we kind of decided in the beginning of 2023, it was almost really close together, this realization, and then doing this meeting. In a whole hands session that we have with the whole company, a 5-minute elevator pitch on what is Kotlin, why Kotlin, what is different from Java, and that also helped evangelize a bit product owners and also some other roles. For example, we had mobile engineers, and they were like, "Oh, but you guys are using Kotlin. That's cool. I didn't know that," because they were using it for Android development, and they felt that's really cool. And yeah, it gave, in the way of spreading Kotlin, we started in our community, now within the company in other communities, and then we move on the next step also, that in our recruiting challenge, if you want to come to MBIO, if you're interested, allowing the candidates to deliver their solution in either Java or Kotlin. So it also solidified for the outside now that, yeah, these guys are talking about Kotlin, and actually, if I'm feeling confident in Kotlin, I can do it. Which is actually quite curious, because, I mean, nowadays, some of our engineers also have not coded in Java for a while, so if they were applying to here, maybe they will feel like, okay, it's nice, I can also apply in Kotlin. And then, yeah, we also had more people attending Kotlin Conf. That's a high jump in 2023. And actually, I have here some stickers for you, 4 or 5 Kotlin stickers that I have from 2023. If I will leave it there for the networking part if you want to grab some, and some pins. And we also did some college workshops on building microservices using Kotlin, which is curious. By the way, if you go to the Kotlin language website, they have a section on explaining why you should teach in Kotlin, or why Kotlin is a good programming language to teach in college. And you can see all of the universities and courses in the whole world. And actually here in Portugal, in Lisbon, we already have 3 universities. ISEL, and Professor Paul, that is here, in Isqueté, which was one of the colleges that we also presented, and they were already super evangelized in Kotlin, but was still an interesting exchange. And also, I think it's Lusófona, here in Lisbon, that are also, yeah, exactly. I was drawing blank on the names of the colleges, but yeah. So it was also I think for us it was also a good way to connect now to a new generation of engineers that we already know that are using in Kotlin, and we are like, okay, we share that interest as well. Let's go forward with that and exchange. And now we reach 2024. Yet again, more colleagues attending the Kotlin Conf, that I think is really relevant. We keep knowing what's happening in the ecosystem, sharing it in-house as well, learning with each other. And I also put today as a milestone. I would say I think it's really nice for us to be here and talking with you and exchanging and learning more, because it shows some commitment to also be part of the community and trying to give back in some way. So going to the momentum on Kotlin, I mean, I don't need to sell you on any of this. I think we already discussed it. Multi-platform from what you were seeing here. I don't know if anyone is using it for data science. Maybe no one is here on that part. But actually in Kotlin Conf last year, they were introducing that they were supporting some sort of Kotlin notebooks. And I was like, oh, okay, even for data science, right? And I mean, even for front end, I don't really like front end, but if it's in Kotlin, maybe I'm going to tiptoe my feet there. I don't know. And it's an industrial language by now. It's, I mean, used by Google for Android development since 2018, that they supported and give it first-class support. Netflix, Amazon. It's one of those languages that has really gained a lot of growth in the past years. I mean, in terms of language itself, less boilerplate code, null safety. Null safety seems like one of those that when you were in Java, then I remember one colleague that was in that team saying, no, in Kotlin it's kind of impossible for you to get a null pointer exception unless you're really messing it up. And then when I switched, I was like, okay, that's kind of true. It's really something different. And yeah, and interoperable, as I said, you can start changing some parts of your libraries, doing some changes here and there that will make it really easy for you to start going. And then some sort of resources here in that sense that probably you are all aware that JetBrains, which is the company that started developing Java, is also the one that develops IntelliJ. And they actually have also a Java to Kotlin file converter. And at the time, that was kind of fun because I didn't know anything about Kotlin. I was like, okay, let's see how it looks like. That's also an interesting just way. Doesn't mean for you to start, oh, I'm going to do everything in Java and convert. No, but if you're starting out, it could be an interesting approach. And then in the documentation of Kotlin, they know their target audience, and there's a bunch of documentation on, okay, comparing it to Java. What's different? If you want to do this in Java and coming from Java and doing this in Kotlin, or if you want to call Kotlin and from Java and vice versa. And then I think the most valuable resource that was shared at the time was actually this free course in Coursera by JetBrains that was really targeted if you're coming from Java and you want to learn about Kotlin. Yeah, you have this. And I mean, I had to put here some small graphics on some surveys, but I have to do this disclosure because, I mean, if you're going to look at it, it doesn't seem that impressive. And of course, there are other languages that are really hyped right now, like Rust and Go. But let's consider what also Professor Paul was saying, that, I mean, I'm almost the same age as Java. I'm going to be a bit in some weeks, around 29 years. And Kotlin is a teenager, 13, 12, something like that. So it's going to be, yeah, there's going to be levels of difference here. Of course, I want to say that Java, since Java 17, Java 21, there's a lot of new things that have improved the language. But what we see here, especially if you're seeing there, Java adoption is kind of the same, maintained the same. And from 2017 to now, from the JetBrains survey, it increased from 2%, which is like basically nothing, to 15%. And also on the Stack Overflow, it's one of those languages that seems to get a lot of love. Doesn't necessarily mean that everyone is kind of using it, because they ask if you're extensively using it in your day-to-day in your work. But at least it's one of those that like, oh, I want to have fun. I'm going to do it in Kotlin. So that's kind of an interesting thing to consider. And yeah, we're reaching our lessons for the road, or as I said, take it with a grain of salt, maybe some considerations. What I would say here is that from maybe what you saw, this was not a linear path, and it was not like a predefined. It was not like a CTO or a manager that was like on the top level saying top down, we're going to start Kotlin tomorrow, let's go. Of course not. It had its also bumps and downs, right? And does not mean today that everyone is using it, but I think in the cultural mindset that we are is that whenever we can, we go for it. But consider your own organization, your own context, your own challenges, and adapt and be flexible to that. One that I think is kind of universal on everything that's like a small advice is, yeah, start small. And I think that really helped because it was that one team that was really strong technically, and really admired within the company in that sense that they were some people that knew what they were doing, and that paved the way for the rest of the teams to start considering it. Of course, doing continuous evaluation. As I'm saying all of this, I was saying that Java is on a good path. And let's say, for some reason, I don't expect it, but let's say Kotlin is not keep improving on some different areas, and we feel that for own specific challenges in our day-to-day is not serving us, we should do an evaluation and maybe consider other options. But I think it's something that we need to do recurrently. Teams should also gather feedback, exchange, and also exchange with other teams and other product teams. And I put there in quotes, I don't know if it's an actual quote, but I hear it, or it's a common sentiment among developers, I think, is that languages are tools, right? Not necessarily every single problem needs to be, oh, I'm going to use this language. And in most of the cases, it's actually agnostic to the language. Of course, it can be some things that are common, but use whatever makes sense for your given context and circumstance. So, yeah, I think that's what I have for you today. I don't know if you have any questions. Yeah.
So, do you think that Kotlin could lead the rank of most used programming languages for enterprises? Wants to grow?
Oh, that's a tough question. In my honest opinion, I would say no, because we know that, or I feel that changing code bases in some legacy companies, or not legacy companies, but some legacy software or big companies, change is really difficult. And if I was to say, for example, now the way our community is also set up right now, we already a lot, right? It was quite easy in the beginning. It's 13 people, 2 people doing experimentation and learning. So I would not say, I would say also that there's nowadays, every new day, a language, well, if it's front-end, if it's frameworks, it would be every day. If it's just back-end, maybe a couple of years that there's a new language. And I mean, Go also had a lot of increase, Rust. So for different kind of scenarios, I do believe that Kotlin will still be growing, but I don't know if it will be like top. Hopefully, I would like to see it. Yeah, you're welcome. Anyone else? Okay. Once again, thank you.
Meant to?
Deixa só o teu prazer baixando. Tens ali Konsist.
Tentando apagar isto.
Tens ali Konsist também. Só nisso.
Só... isto. Okay, so yeah, let's jump to the topic. Today I'm here to present you a bit about a framework for Kotlin that's called Konsist, and basically how you can use it, what's these two advantages, and why maybe you would like to use it. So jumping right away. So first, I will tell you why do we need another tool. We have plenty of them, so why the hell do we need another one? What is actually this tool about, and how we can use it with a small demo, with live coding. Hopefully everything will go well, let's see. And with a QA at the end, but if you want, you can interrupt me at any time, just ask. So first, who am I? For those who are good with movie reference, no, I'm not Spider-Man. I'm just a software architect. I'm currently working with cloud native solutions here in MBIO. Mostly work with Kotlin and Spring Boot. So in my day-to-day, I focus on providing information to our users regarding, so after they buy their vehicle, and information regarding warranties, if your car needs to go to factory to get, because it has a factory issue, so a car needs a recall, so we show this information to the user, buying contracts and benefits to keep customers on our end, and we target multiple consumers, so mobile application that we have on Mercedes, our head unit, so there's a small application there that we also are responsible for showing information to the user, and of course our website and dealers. So a bit of personal stuff. I like a lot technology, otherwise I would not be here, and like good challenge and problem solving, and watching sunsets. So also I'm keen with electronics, robotics, and good music. Jumping to the topic. So why do we need another tool? So probably you already heard about linters and what they do. Kotlin has a couple of them. So probably the most well-known is KT-lint and also detect. So these are probably the most well-knowns for Kotlin. And what are these tools? So they are linters. What's a linter? Basically, they do they deal with certain topics, and in case of KT-lint, this tool is mostly focused on your syntax. So checking if your spaces, if you have like too many spaces on your code, or if your names in your functions are ordered, if you have them all in one line, or if you have them with separate by new lines, if you end your functions with the last argument with a comma, and for example, wildcard imports, so if you are allowed to have wildcard imports in your code or not, basically just at the syntax level. And then you have detect. That actually started with, not with that much focus on syntax level, but rather on detecting other stuff, like code smells, code complexity. For example, if you have lots of parameters in your functions, or for example, if you are using, so for those who came from Java, in Java we have streams, in Kotlin we have sequences, so detect can help you with that. For example, if you are using too many chained operations in a list, it will warn you and say, okay, probably here you should use a sequence because it's a lazy operation and it's more performant, and also detects some bugs like forced casting. If you are using reference equality, so checking if an object is equal to, so checking if two references are exactly the same. This is not a usual pattern that you should use, and mostly topics around that. In the latest releases, they are also focusing a bit on syntax topics, but yeah, these tools are mostly about that, and they run so statically, meaning that you don't need to execute your program to get your results, and basically you have your command line or a plugin in Gradle or Maven, and when you build your application, it will warn you about this. Also, they have integrations with your favorite editors, let's say, to help you a bit using the tools. But what they don't have, so they are probably hard to extend for certain topics. For example, such as architectural code verification, meaning that you want to check your code from an architectural perspective. So if you follow a three-tier architecture, onion architecture, and all of that. And they also don't have support for checking properties, actually properties for your code, for example, or coding standards, let's say. For example, saying that every function in my controller should be written using coroutine, stuff like this. And yeah, that's why we have these other tools that will help you on that. One of them, it's actually ArcUnit. We have this tool. For those who don't know, this tool actually helps solving a couple of these problems that I've mentioned, but this tool is targeted for Java. The tool itself, it's not actually, it doesn't work only on Java because it works on bytecode level, so it will work on every language that uses bytecode by JVM. So it works also on Kotlin and on Scala and whatever. But what's the problem with this tool? This tool is not Kotlin native, and probably for those who have used this tool, you will end up with lots of troubles if you want to say properties for your code that are specific from Kotlin. For example, properties such as coroutines, companion objects that you don't have in Java by design, and you will need to tweak this tool to get your results. So you will have lots of effort to get what you need. And that's why we need to come up with another tool to help you solve this and target specifically Kotlin. And this tool is called Konsist, and basically Konsist's focus on checking properties about your code following some code standards. It's not focused on linting or on syntax, so if you have your arguments in every line or whatever, it's more about coding standards and make sure your code base follows that. It's obviously, since it's directly targeted for Kotlin, it's type safe, as a Fluent API, and it's fully compatible with existing features from Kotlin. And also another important point that I haven't talked about, it's about Kotlin multi-platform. Since it's targeted to the language itself, so to the source code, it actually supports Kotlin multi-platform, and the other tools don't, because they are targeting bytecode, and JavaScript is not bytecode. And yeah, basically that's it. They support some features like declaration checks, so class naming, package starter, so your modifiers to check if your classes are all private or are all open or closed and stuff like that, and annotations and all of that, and architecture checks that, like I mentioned. So, and what's most important is that you can keep doing these verifications without running your code, and you can do it actually by writing tests. So you usually write unit tests for your code, and you can use the same approach with this tool to write these properties for your code. And how can we do it? So we will see this with a demo, of course. And we will use a toy application. So, of course, Kotlin, Spring Boot, a vehicle API, because we work with cars. So what else would it be? And this API is basically an API with CRUD operations over vehicles. And data is persisted in Postgres database. So let me jump to the presentation. Okay. I hope it's visible. If not, yeah. I will avoid jumping to presentation mode, but if you want me, I can do that. Let me quickly view should be here, right? Yes. So maybe now it's best. I think it's command 1. Okay, so to start, basically, as I've mentioned, so this application is an application with focus on operations on vehicles. So a usual application written in Kotlin with a controller, services, repositories, and your database resources, and a couple of models and DTOs for returning information to the user in the controller. So basically, this is just a basic controller. You have operations to get all vehicles, and so we actually have two, because I decided to follow two approaches. So one, it's returning all vehicles that probably you should not use if you have 1 million cars in your database. And then we have a paginated version that returns pages for vehicles. Then we have the usual operations. So get by vehicle ID, create a vehicle, and update your vehicle, and delete. So we are not immutable, but that's life. And then we have, so probably you noticed we are using coroutines in our code. So our application is fully asynchronous, and we take advantage of these functionalities. And we use, so we have our entity, defining our vehicle table with an ID, so our primary key, make model, VIN, that's the identifier for your vehicle, and the year. We have a couple of extension functions to transfer between your what's coming from the controller and your entity, and from the entity to the return back in the controller to the user. And we have a usual repository with one operation for pagination, and it's also reactive, of course, because it wouldn't make sense to have a blocking repository here. And we have a couple of DTOs that I will not jump into to avoid wasting time. And our service, which is pretty straightforward with operations on the repository, nothing fancy here. just usual code that you are all used to do in your applications. Now, what's important is this is not the focus actually for the presentation. We have here a couple of folders. So we have tests for our application. Obviously, they are not fully extensive because this was just a demo. And then we have separate folders for our, let's say, tests that focus on your code structure or architecture properties or what you want to call them, actually. And this is actually a good practice. We could have them here on the test folder, but I think it's best to use a separate folder to have these types of tests, since they are not actually tests for your code, but rather for the structure of your code. And then we have here ArcUnit that I will just quickly brief. Basically, this is the project that I've mentioned that you can also use because this is used in Java, so you can use it on your code. And then, so just going briefly, just a couple of constants to highlight the packages for my controller services and whatnot. And then how this tool works is basically you have this annotation like you have when you use JUnit or other annotations. And I will jump through this. And instead of having a test, you have an arc test. So it's pretty much the same that doing a unit test. And then you have this argument that you always need to have. So you need to hand over these to these functions, which are basically the classes that you have in your code for this framework to analyze. And you have this like structure defining, for example, in this case, so this defines that I have a layered architecture, and I have actually 4 layers. One is the controller, service, persistent term resource. That's defined by the packages that I have above. And I mentioned here that the controller cannot be accessed by any layer, which is actually a good practice. So you will not call the controller, but the framework will for you. And then we have the service layer that hopefully only your controller will be calling, and no other layer will call the service layer. Of course, the service layer can call itself. And we have the persistence that should be called by the service layer. And yeah, basically this is the structure. It's very simple, we might think. And there are other things that you can do. So say that I have all the classes in my code that are annotated with the REST controller at REST controller should be in the controller or should end with the controller suffix and stuff like this that I will jump. So you might ask, okay, so why don't you use this? Yeah, because like I mentioned, you will end up ending with a dead end in certain topics. For example, if you want to say this, controllers and service, static properties should not be null. So if, for the ones that know about Kotlin, so we don't actually have the word static. We rather have companion objects. And if I try to run this, you can actually see that this already fails because I ran it previously. If you run this, you will see that this will fail. Let's hope for it. Let me see if I can show the I don't know the shortcut. Ah, okay, it opened. So yeah. So basically this will fail. Okay. So this will fail saying that, oh, you have something that violates this rule, and it will say where is the violation. So it's in this field, the companion, and you ask, what the hell is this dot companion? I didn't even wrote a class called companion with a modifier public. So yeah, I don't know what it is. And if you try to jump, it will go just to the first line of the code, and you won't get anything from this. But we know that this is because you see the word companion, and you will notice that we have in this controller a companion object with our logger instance. And yeah, what's actually complaining is that this companion is public, and inside, so we have static object that is actually the companion object that is public. And you can see this, hopefully we will have it here. Yes, so I don't know if you know this too, but if you go to Tools, Kotlin, and show Kotlin bytecode, you will get what's going on here. Let me just, and you can, of course I will not read the bytecode, neither you. You can just press decompile, and you will get an approximate version of what looks this code if it was written in Java. And you can see here somewhere, I can probably companion, I don't know how to write. So yeah, you can see here that is a public static final class companion. That's, well, what you get after decompiling this. And you actually have your logger somewhere around inside the companion. Where is it? So it's here. Let me check. OK. So the logger, it's private. So it's everything fine with the logger. The problem is the generated companion object. And what, so you can right away see the problem. What can we do about this? If I command 1. So what can we do about this? We can tweak our code and say, so let's fix this and check for classes that are called companion and have these, exclude these from our checks. So I will just exclude the companion object, and I will run this, and it will succeed, hopefully. Let's just wait a bit. Yes, so we have our test screens. So who doesn't do this from time to time? Just add something stupid to our tests just for the tests to pass. You shouldn't do that. But yeah. So now, jumping to the tool that we are interested in. So we have like, by the way, I'm also, so this was done using ArcUnit with ArcTests. For testing purposes, I'm using Kotest. I don't know if you know what Kotest is. It's basically a framework for testing, targeting Kotlin also. You have JUnit. You can use JUnit if you want, and that's also the magic from this tool. You can use whatever framework for testing you want, if it's JUnit, Kotest, or other frameworks out there. You can use it. For example, maybe I can start with JUnit. In this tool, you can write stuff like this. So you can write specific properties about your code and about and properties that are actually targeted to JUnit for those who use JUnit. So you can here see, so basically this is a normal test, a normal unit test with a nut test. And you have like this class Konsist that is from the tool that we are using. And then you basically specify from where you want to read your files. You have several options. I want to read only my test files. I want to read tests. I want to read all the files from my project. I want to read production files. Production files are those files that are not in the test folder. So you can exclude tests. And then you can mention, read me just a couple from this package, from directories, external files. So support for several topics. And then after you scoping your files, so constraining the space that you are searching in your code base, you will actually go into the details. So in this case, what I'm focused here is all data class properties should be defined in a constructor. So basically, this means that every class that has a data, so it's a data class, all properties that you have should be in the constructor. So you can't have like properties inside of the data class. And basically this is very simple. So you just mention classes with data modifier. You have lots of operations that they have out of the box. Let me just check if this is okay. So you can filter for constructors. You can filter with annotations. You can filter by modifier. So with public modifier, internal. Yes, you can. They have actually also the exclusion part without, just to make it easier for the developer. And then, so you can see this Fluent API. You pick on the previous step and you iterate over it. After getting our data classes, we are focused on our properties, so the declarations that we have in a data class. And we want to assert that these properties are all defined in the constructor. They have these out of the box, so you don't need to go, so I will not go into the details, but they have these properties out of the box to help you, and you don't need to make lots of effort. So if I run this, you will see that probably the code is okay. But if I go here to my DTO, and for example, so let's put here valx, I don't know. And then if I run again the tests, so it will fail. So, yeah. So like the previous tool with ArcUnit, it will fail mentioning the file and the line. So 22.5, that's actually very accurate, saying that this was violated one time by this property declaration topic. And yeah, basically that's it, the gist for this tool. A couple of things regarding the output that I can mention right away. So probably this is still not very user-friendly, but there are things that can help you. For example, plugins that we can have in IntelliJ that will pick up the link that is displayed in the console, and you can click directly here in the console, and it will jump to the editor. So it will help on that. But yeah, this is still a very new project. I think it's actually in, let me see, but I think it's actually in version 0, maybe, or not. I have it, yes, 0.16, so don't use 0 dots in production, but since this is actually testing code, it's okay to use it. But yeah, it's actually a very fresh project. And I will jump to a couple of other. Probably I will just jump to the stuff that is done. Maybe jumping to an interesting example that, let me see. So this is the same that I've mentioned before. So in ArcUnit you can say, how is your architecture? So this is the same representation using this tool. Basically they have functions, helper functions that help you on this. And you can say the layering of your project, and it's even more, in my opinion, friendly to the user, saying that controller depends on service and whatnot, so the properties that you want. I will focus on one. Let's see if I can find it. Inject. Yes. For example, if you are using Spring, you probably know this by heart, so you should not use field injection. Field injection is a bad pattern for many reasons. and you should not use it, you should use constructor injection. And you can actually detect these using this tool. You can mention these tests, so bring all files from my project, check all classes and properties, and no property that's inside my class should be annotated with an auto-wired, representing a field injection. So everything will be done in constructor level. You can also, of course, improve this by checking that you are not that you don't have setters, or that you are not doing method-based field injection. But yeah, you can iterate on top of this. And another one that probably most of you follow is no wildcard imports rules. They also have support for that. So you just go to your project, you check for your imports, and you make sure that it's not a wildcard. And you can do that also. Another interesting one is the one representing the, for example, this one might be useful. So usually this is not, I mean, this is not a very accurate and not one size fits all, of course. But you might be interested to say that I don't return collection types in my controller, because you always want to return, you don't want to return a collection, either because you don't want, for example, to fall in the pitfall of having a million of vehicles to be returned. Of course, you can go over it by just returning a wrapper, but yeah. This is just to illustrate that you can do these types of stuff, and it's actually, by following some guidelines, it's actually a good behavior to return an object instead of a collection, because objects are more extensible, and you can just add properties on top, and it's more backwards compatible, and you will avoid breaking your API more often. And basically, that's it. So you can also, for example, declare properties over your entities, saying that, okay, I have a table and I should have a primary key. In this case, this is identified by the annotation table and by having the @id in one of the properties. And of course, probably this has a bug, because you should not have two @ids. But I actually don't think that the compiler will allow it, because it will just say, okay, there's two IDs and you can't use them. But anyway, you can have, like here, instead of any, you can have, you can use regular Kotlin, so you can just say at least one or one. You can have operations on, they have also extensions, and you can go over these to get so you can say whole, or you can just get, you can map them, you can do whatever you want to say, to express your properties. More, let me see, I think I have here one on reactivity. For example, you can also mention, I mentioned that this does not focus on the order of your code and something and those properties, but you can do that. You can also say that, for example, my companion object is always in the end of my code. I think I have that example here. Yes, so it's a bit trickier, because you have to go over your code and check in your class and first get the companion object by filtering out the elements for your class. So just get me my objects, and don't include nesting, because otherwise it will go inside these companions and get the objects inside of them. And you get the last one, so you are trying to find the companion object, and then you do the same and get the last declaration of your class. And basically what you need to see is either I don't have a companion object at all, so it's okay by default, or my companion object is the same as my last declaration. So matching that actually I have the companion object at the end. More. Maybe the one from reactive. Okay. Yes. So first I will show you the code for ArcUnit, just for you to see what's the hard part here. So I try to do the same in ArcUnit. What's the problem with coroutines? In Java, we don't have this word also. And so basically, coroutines, it's all about asynchronous operations, and they are based, the implementation from Kotlin, it's based on two terms. So it's based on continuation passing style and on suspending functions. So continuation passing style is actually a very old technique that was coined in 1970s by John Reynolds. And so you can see this is a long way ago. And it's, like the name says, continuation. So it's everything about a continuation. And if you do this, if you check the code, I have here, so this is a coroutine. And if you decompile this, you will see actually what's all about this continuation. So let me jump. So you will see that every single method that has a suspend, we will end the last argument, it's a continuation. So basically, it's something that will save the state. And after we resume, so we go into suspend mode, and after we resume, it will pick up the state and continue from there. Hence the name continuation. So basically, it's that. So if you want to check this using ArcUnit, since it's targeting bytecode, you need to know this. You need to know the technical details, and you will actually check for this. So you will check in your code. So let's find all my classes in my REST controller that are public, and also you have to filter out these ones, because these are what's called synthetic annotation. That's basically a code that's generated by Kotlin. And you can see here, this is closed, but let me just see if I can show you. Again, not this one. You can see here, you have these annotations saying synthetic method. So basically, these are generated methods by Kotlin, and you have to filter out them, because you don't want to go into the details of generated stuff. And we also want to remove, this is of course needed, because we want to remove the ones that return flow, because in this case, so flow is also part of coroutines when you want to return multiple values in a stream, and these are not suspend functions in this case. So you just want to return a flow, so you have to filter out the ones that are returning this type. That's why we did that. And now the tricky part. So either we have a return type that is flow, or it should be a coroutine. And the tricky part is here that we have to implement this check by our own. And we have to extend ArcUnit and go into the details, checking the parameters types for our method, and so just juggling a bit around with type erasure and all of that, and check that it's from continuation class, basically. And that's what you need to do here to make this work in ArcUnit. And many examples are for example, I have here another one that I wanted to check the return type, that it was annotated with something. I also had to do the code for that. So check the method, return type, check if it was annotated or not, because it was we didn't have support for these out of the box in these two. and how it is on Konsist. Basically, it's pretty straightforward. You just filter out the classes from your project, filter, once again, the ones that are annotated with controller. We go to our functions, and we just assert what we want, checking that it has the suspend keyword, because this is targeted to the source code, and checking that the return type is from type flow, basically. And that's just it. We didn't do anything else. No extensions needed. And yeah. You can also do other interesting stuff. So if you want, you can even say that check, please, that my code, every class has a test. So if you want to reach the golden metrics and have tests everywhere, to make sure that your code is fully tested, of course, you should aim for good testing and have your code tested. You can do a quick check using this tool, and you can just check that get all classes from production. So I'm excluding the tests themselves, because otherwise I will test the tests. And I'm picking up the classes and check that all classes as tests. If you see this is disabled, of course, because I don't have tests for all my classes, because this was just a demo. And if you see it, let's hope it runs. So you will have, once again, every line of code that's missing, or every class that's missing a test. So the main application does not have test, the controller, vehicle, and whatnot. So, but probably you are thinking, maybe this doesn't make that much sense, because I will not go and test, for example, my DTO. That's just a data class. I will not test code that is vanilla code that doesn't need testing. This is pretty straightforward and already tested by the Kotlin guys, so we won't have a bug here. So we will just exclude this. No test needed here. And you can do that also in the tool, because these are just normal operations over lists, collections, and over your code. And you can mention that, okay, I will check that every class except data and value classes have a test. And you can say that by excluding, like I mentioned before, by using these functions that they have, you exclude classes with modifier data and value classes. But you could also use without data modifier, because I think they have it. Yes. You could also be explicit. I just wanted to give another example of the API. Without value modifier. You could do it also like this to filter out the and if you check this, hopefully we will get a smaller list, but we'll still get a list because we don't have tests for every class. But yeah, you can filter out stuff that you don't want, or make specific scenarios for your use cases. But yeah, as you can see, the list dropped down, so we are just missing tests on the main application that probably we should exclude, because it's also, I mean, the class for the main application. This one we will also not do at least unit tests that will have any outcome here, and we'll just focus on the vehicle. Also, the entity class probably we are not going to test. We are going to test our integration with the database, but not the entity class itself. And probably exceptions also we are not going to test, and all of that. So you will filter out following your rules and end up with what makes sense for your application. And yeah, basically that's it. you can do lots of stuff. I have here one example that is a bit more advanced, and you need to actually code a bit more. Of course, they don't have everything out of the box. It would be nice. But since we are using Kotlin, we can even go and do extension functions on top of their library. And we can have like our own set of rules in some helper library or something like that we import in all of our projects, and we have our standards. So basically, in this case, I'm saying that every property should be declared before a function. So you should declare properties on top of your class and then your functions. And you can do it by going through their API, checking the declarations, and finding property declaration, functions declarations, and basically checking that the index is from one is less than the other. But yeah, here it's a bit more complicated because you need to know the interfaces on their code base and to get into this. But yeah, I think it's still pretty good and shows the potential for this framework. Yeah, basically that's it. So in the end, this can be, of course, since this is mostly like unit tests, you can integrate it on your CI/CD when you run your unit tests. So your PRs will fail if they don't have all of these green. And basically, these are the advantages of using these two. Yeah, I think that's it on my side. And if you have questions or something, just ping. Oh.
Yeah, I have one question related. Normally we use detect and killing, and those tools support defining this type of checks via YAML configuration file, let's say. Does Konsist also support that?
No, Konsist is only a programmatic tool. Okay. So you have to write code like you were writing unit tests.
Okay. And yes, just one more. Have you used Konsist for like getting statistics out of the code, like number of private methods, number of internal, something like that, instead of just for making sure that the code adheres to certain convention?
That's actually a good point, but no, we haven't. At least
is it possible?
In my team, we haven't used it. Since this is actually a pretty new tool, but yeah, we intend to use it. So we had ArcUnit, but then it was causing more troubles than solutions. We deleted it, and then these two pop up. We will hopefully integrate it on our projects, but yeah, we didn't use those type of metrics. Yeah.
Consider using something like Sonar with the
Yeah. Yes. We also have that, and yeah, basically from there you can get coverage details, how many tests you have, and all of that. I don't know if they have support for saying how many private methods you have or not, but yeah.
I was curious about the certain defining some checks on the code and checking if my code has. I gave as an example the private method, but more details related to the bytecode itself, if it's possible or not.
It is.
I'm not sure if Sonar does that, or if it's just general statistics based on.
You can also have your own set of rules.
Okay.
You can write your
Yes.
own plugins.
Yes.
Maybe
Yes.
something will come up, like using these to write plugins
Yeah.
for Sonar.
Maybe. But yeah, you can for sure use this tool. So you just need to write tests, and you can, since this is code and this is actually reading your source code, you can filter out, and even if you want to integrate with benchmark tools to get those statistics or something like that. So basically, I don't know.
Yeah.
Yes.
I know this may be a curveball, but I will ask you regardless. I don't need convincing about the relevance of such a tool in a production site. I understand the need, but for example, we at TZL, we have a second year software development course, laboratory, software laboratory, where we use linters. I know it's a difficult question, but I just want to know what is your take on it, just top of your head. What would you think if we use such a tool by adding this tool, Konsist, to our set of checks when the students are producing the software that we intend they produce during the semester, during that course. Note that the course is simply about producing a software solution for a given problem. It involves backend using not Spring at that time. We use a more simple framework. Spring is used on the third year, but HTTP4K, right? That's right, HTTP4K. And on the front end, vanilla JavaScript, React, and whatnot comes later on. But still, we have restrictions. We try to impose linter rules. What would you say if someone, and you imagine yourself 2 years into a course, a program, and be faced with the imposition of using this tool? Is it difficult to use? I know it's difficult.
Yeah, it's not that the question is difficult. So yes, it's exactly. I mean, in my opinion, I think these tools are useful, but it's also kind of a mixed feeling, because from my experience, I also use such linters, so like KittyLint or Detect, but they were causing more problems than solutions. And at some point, we need to do workarounds on our code just to deal with the fact that we need to enforce the rules and pass the checks. And sometimes there are exceptions. You will, at some point, will of course end up there. These tools, I think they are good in the sense of making habits for yourself. So I will not see these tools like you are forced to use them because you need to use them. It's more like, okay, just try it out, use them just to gain good habits for programming. So structured code, making sure that, for example, probably one scenario is you have files spread everywhere in your project, and you want to keep a good structure and have certain files in one package. So these tools are good for that, for creating habits. After you gain habits, so every programmer has his own style, own coding style, of course, and this is very important when you are working in a team, because in the end, we are humans, and we see the code from other people by pull requests and other tools, and we see and we have our personal opinion. And in the end, we should not get too much attached to our code. I know that's difficult, because we also we like to be attached to the things that we do, but we should not be too much attached to that. And these tools come in hand on those scenarios, because okay, these are the rules, they are defined by the team, just follow them.
So if I understood correctly, it's a good idea to use
Yes.
such
Yes,
tools
I think.
as early as possible.
Yes, I think so. They give work to maintain, especially this one, because you need to code. But yeah,
it's not about what they teach, because I think you're right. Code is most, when we work in a team, code is not about us, it's about the solution itself. But I fear that it adds complexity
yes,
to the task.
Yes.
And,
it's true. So yeah,
it still does. Right?
that's the downside. So you will.
But if it is set up.
Exactly. You will probably do it once and you are done.
We do
So
it, the professors.
exactly. So
Students simply run through it, and if
exactly.
it fails,
Exactly.
they try
Yeah.
to. Okay,
Yeah.
thank you.
More questions?
Can this tool be AI powered to write code more easily
AI powered, you can use, for example, I don't know if the professor has it enabled, but you can use Copilot.
Yes, I think so.
Yeah, so yeah, you can use Copilot just to generate the code, because it will get the information that they have trained in Copilot and public code bases and so on to get code generated for you. The tool itself, it doesn't provide support for AI generation mechanisms, and I don't know what's their plans, but yeah, basically that's it. No more questions? Okay, then I guess it's all.
Turn the stream off.
Yeah.
Yeah. Okay. Go to the stream on while you talk.
No, you can
Yeah?
switch it.
Yeah.
Okay.
First?
Yeah.
Yeah.
Categoria.
Yeah.
Obrigado, pessoal.